జాయిన్ అవుతున్నారు సార్. 92 అయింది అప్పుడు ఆల్రెడీ. 126 అయ్యారు. సార్ జాయిన్ అయ్యారు సార్, జాయిన్ అయ్యారు.
ఇంతకుముందు ఏదో ప్రాబ్లం వచ్చినట్టుంది, అది ఎక్కడ పోయింది
సార్? కాలు ఏదో స్నూర్ అవుతుంది. ఒక్క నిమిషం ఓపెన్ అవుతుంది.
నాకు ఓపెన్ అయింది, చేశాను.
సార్ ఆల్రెడీ జాయిన్ అయ్యారు స్టూడెంట్స్.
Okay. Some problem was occurred actually. Okay. Yeah. Right. Hello, dear students. There was some problem actually. Now it's rectified. I don't know. So during the break, there was some. Okay. Right. Okay. Sir, don't extend class because tomorrow is. Okay. Yeah. I'm not going to extend. Up to 9 o'clock only I will take, no problem. Right. See, up to 9 o'clock. At 9 o'clock exactly I will stop. Okay. So let us see the questions based on this. Some questions let us see. Yeah. I'm sharing the screen. Yeah. The questions are. Yeah, dear students, see the questions here. First, let us see the questions based on this. Yeah. 6th chapter. See this question. 2 alternators. Question number 30. Question number 30. Question number 30. 2 alternators M1 and M2 have been properly synchronized and connected in parallel to a common bus bar. If there is no load on the bus bar and the field excitation of the second alternator M2 is increased gradually by a small amount from its normal excitation, for which the load induced E1 and E2 of the two machines are equal, the armature reaction due to circulating current would be. See, this is your previous IAS examination question. IAS examination question. 2 alternators M1 and M2 have been properly synchronized. And excitation of M2 is increased. When excitation of M2 is increased, what will happen? When excitation of M2 is increased, circulating current, armature reaction due to circulating current is demagnetizing for M1, magnetizing for M2. So what is the answer? Yeah. Field excitation of the second alternator M2 is increased. When M2 is increased means it must be demagnetized. M2 must be demagnetized. M1 must be magnetized. So answer is A. Answer is A. Magnetizing for M1 but demagnetizing for M2. Demagnetizing for M2. Right? Yes. So this is your answer. A is your answer. Okay. Yeah. Now, next question. Let us see the next question. Second question. Second question is this one. 31. Question number 31. You see, two alternates M1 and M2 of same rating excited equally. Two alternators M1 and M2 rating excited equally are connected in parallel and supplying for a pure resistive load. If the excitation of M1 is increased, then A bit M1 is operating at lagging power factor and M2 is at leading power factor. What is your answer? Two alternators M1 and M2 of same rating excited equally are connected in parallel for a pure resistive load. If the excitation of M1 is increased, then the excitation of M1 is increased, it must be demagnetized, correct? It must be demagnetized. Demagnetized means what should be its power factor? Power factor must be lagging. Power factor must be lagging. Okay? So, power factor is lagging. Second machine will be, power factor will be leading. So, your answer is, as excitation is increased means M1 must be demagnetized. Demagnetized means it should be operated lagging power factor. And M2 must be leading power factor. Okay? Yeah, fine. That is A. Answer is A. But your doubt is pure resistive load is there na? Here. Your doubt may be pure resistive load. When resistive load is there, power factor may be UPF, you may be thinking, no? No. Lagging and leading. Fine. I am going to explain this with phasor diagram. But before that, let us see. I will come to that question separately. All these are there in your booklets. Question number 32, you see? 32. 32. Two alternators running in parallel and supplying a fixed load operate with same excitation voltage and same armature currents. If the steam input to the alternator 1 is increased, when steam input is increased, A, B, C, D. These are the multiple select type of answers, multiple select type. MSQs, multiple select questions. See, statements. A, alternator 1 shares increased IA with improved power factor. Alternator 1 shares increased IA with worsened power factor. What is the answer? Tell me for this. Operate with same excitation voltage and same armature currents. The steam input alternator 1 is increased. When alternator 1 is increased, it will share more current. When steam input is increases, its active power increases. Active power increases means definitely current increases. Power factor also increases. Active power factor. But other machine, power factor is decreased, current also will decrease. So what is your answer? A, alternator 1 shares increased IA with armature current IA with improved power factor. First statement, A statement correct. And B, alternator 1 shares increased IA. No. C, alternator shares decreased IA with improved power factor. No. C is not correct. What is that? Answer will be D. D is alternator 2 shares decreased IA with worsened power factor. Correct. Answer is A, comma D. A, comma D means what is your answer? B. B is the answer. B is the correct answer. B is the answer. Fine. Next. Next one. The next one. Oh. Yeah. Next question. See here, 33, question number 33, you see, 33. Two alternates running in parallel have the same excitation voltage and armature current. If excitation alternator increase, that is also same. You can go through that because it is there in the answers are there in the table. Yes. All these are examination questions only. Question number 34. When two alternators are operating in parallel and perfect synchronization, their synchronizing power. Synchronizing power is perfect synchronization. What is the synchronizing power? Synchronizing power is 0. No synchronizing power. It will be 0. Okay. Next. See question number 35. Question number 35. If the field of one of the alternator running in parallel is adjusted, it will. When field adjusted, what will happen? Reduce the speed? No. Speed won't change. Change its load? No. Change its power factor mainly. Change its power factor. Change its power factor. Okay. Yeah. So these are the questions. You just to go through whatever we have discussed with your knowledge, you can able to answer all these type of questions. I have given so many questions. You go through that, you can able to answer. I not necessary to be discussed. Fine. Okay. Yeah. Then coming to, as I told now, first one, two alternators M1 and M2 operating at UPF. The question is, alternator is supplying for two alternators. The question, whatever is given, two alternators operating in parallel, supplying to a pure resistive load. Pure resistive load. No? Yes. If the excitation of machine 1 is increased, then what is the power factor of machine 1? Power factor of machine 1 is equal to dash. Power factor of machine 2 is dash. Power factor of machine 2 is dash. What is your answer? Tell me. Excitation of machine 1 is increased. Its power factor will be lagging. Its power factor is leading. But even though load is pure resistive load, in spite of pure resistive load, the alternator power factors are lagging and leading. The students, those who are seeing these questions very first time, they will go for answers are UPF, not UPF. Earlier I have shown the questions in the question bank. It is not UPF. One is lagging, one is leading. See reasoning. Reason. You can see with phasor diagram. So for example, this is one alternator. This is another alternator. Both are supplying for a pure resistive load. Fine. Yeah. Pure resistive load means load will absorb only active power. Say this is V and this is E1, E2. This is supplying IA1 and this is IA2. So the load current is equal to IA1 plus IA2. That will be resistive load. Therefore, this is the current I, total current. That is equal to IL, say. That is IL. Load current, I is equal to, both are same. That is IL. Okay, that is I. Both machines are operating at what power factor? UPF. Pure resist load means if E1 is equal to E2, they are operating at UPF right now. Both are operating UPF. Load power factor UPFA. But when excitation of machine 1 is increased, then synchronizing current will comes into picture. No? Yes, synchronizing current will comes into picture. And the synchronizing current is what? Synchronizing current is a reactive current. This is ISY say. And this is ISY. That is reactive power. Reactive power is circulating only inside of the machines. It do not come to the load. It will not come to the load. It will circulate only inside of the machine. That reactive power is delivered by the first machine. Reactive power is absorbed by the second machine. So therefore, in first machine, both active power is there, reactive power is there. Both active and reactive power is there. Now, is it UPF? No. Machine 1 operated, machine 1, it will operate at lagging power factor, but machine 2 operated leading power factor. Leading. But what is the load power factor? Load power factor is UPF only. Load power factor is UPF only. Load power factor UPFA. But machine power factor inside of the machines, they are operating at lagging and leading. That you can show with phasor diagram again. Phasor diagram with more clarity. See, initially, this is V, terminal voltage V. IA1 say unity power factor. This is IARA, IAXES. This is the power factor, unity power factor, phasor diagram at UPF. This is IARA, IAXES, first machine. But second machine, this is V, this is IA2, this is IA1, but IARA, IAXES. This is E2. Fine? Yeah. So this is the power factor at UPF, unity power factor. This is the power factor at UPF. Okay? Yeah. Unity power factor. But when excitation of machine 1 is increased, say. But when excitation of machine 2 is increased, E1 increases to E1 dash. E1 increases to E1 dash. E1 is increased to E1 dash. Yeah. Now this is ESY. ESY will comes into picture. When this is ESY means ISY. This will be ISY. This is ISY. Synchronizing current. Now what is the resultant current you see? Resultant current is in the first machine both. Resultant of these two. Resultant of these two. This is first machine current. IA1 dash. But for second machine, resultant of this and this, that is this one. Okay. IA2 dash. Therefore, this is the power factor angle for first machine, but this is the power factor angle for second machine. Therefore, IA dash lags. Lagging power factor, IA dash lags V. But IA2 dash leads V. Leading power factor. The leading power factor. So, you need not to draw all the things. When excitation of alternator increases, it will demagnetize. Demagnetize means lagging power factor. Under excited machine will be magnetized. Magnetized means what is its power factor? Leading power factor. Power factor should be leading. Okay? Yeah. Next. Then I will give another question. See. The question is an alternator supplying to An isolated alternator, single alternator. Now the question is an isolated alternator. Isolated means important question you can find observation. An isolated alternator. An isolated alternator supplying to a pure resistive load. Supplying to a pure resistive load. An isolated alternator supplying to a pure resistive load, operating at UPF. If the excitation is increased, then its power factor will be, is A bit, lagging B bit, leading C bit, UPF D bit, none. What is your answer? Tell me. An isolated alternator what is the answer? An single alternator, an isolated alternator supplying to a pure resistive load, operating at UPF. If the excitation is increased, then its power factor is answer is UPF only. UPF. Because single alternator, it will always operate only at load power factor. Isolated means single alternator. This is single alternator. Isolated means what? Single. Just like your laboratory. Only one alternator is there. Only one alternator. This is V and this is I. So, single alternator operating at UPF. The voltage will be in phase with current, na? Yes. Now this is IA, and this is E. Right? This current I is equal to IA also. Right now it is operating at UPF. Machine is operating at UPF. Operating at UPF means it will take only active power. Load will take only active power. Right? Now, if you increase excitation, my question is, if you increase excitation, will it deliver reactive power first of all? Will it deliver reactive power? No, it will not deliver. If it is deliver reactive power, who is there to observe that reactive power? Where is the path for reactive power? There is no path for the reactive power. Earlier two alternators are there, na? There was path was there. Which path? Second alternator is providing the path for reactive power. It is delivering, it is observing. Load is resistive load. Earlier also we have taken. But here thing is, load is only resistive load and alternator, there is no path for that. It cannot deliver any reactive power. Machine operate only at load power factor. Active power only exists. UPF only it will operate. So, single alternator, isolated alternator, always operate only at load power factor, irrespective of excitation. It will operate only at load power factor, irrespective of excitation. Right? Yeah. Single alternator power factor cannot be controlled. The power factor of an isolated alternator cannot be controlled. It will operate only at load power factor. Let me write this statement. An isolated alternator will always operate only at load power factor. Load power factor irrespective of excitation. Irrespective of excitation. Isolated alternator will always operate only at load power factor irrespective of excitation. Power factor of single alternator, power factor of single, and isolated means what? Single alternator. That is single alternator, not connected in parallel. Power factor of isolated alternator cannot be controlled. Isolated alternator cannot be controlled. Cannot be controlled. The power factor is decided by only load. The power factor is decided by the load. Decided by the type of load, that's all. Decided by the type of the load. Decided by the type of load. Okay. Type of load. And even, dear students, even if the machine is 0.8 lagging, say, load power factor 0.8, then machine power factor also say, machine power factor of 0.8 lagging only. If it is connected RL load 0.8 lagging, machine whatever you do, increase excitation, decrease excitation, its power factor is same. Power factor will be same. Okay. Now, let me give one more problem. Yes. Yeah. See, previous GATE 2004 examination, the question is for 2 marks. 2 marks. The question is 2 3-phase star connected alternators are to be parallel to a set of common bus bar. The armature has per phase synchronous reactances. Per phase synchronous reactances of 1.7 ohms and RA 0. The line voltage of first machine is 3300 volts. Okay, and that of second machine is 3200 volts. Okay. Then the synchronizing current will be the synchronizing current per phase. Is A bit 16.98 amperes, B bit 29.41 amperes, C bit 33.96 amperes, D bit 58.82 amperes. 58.82 amperes. What is the answer? Yeah, answer is yes. See, He has given E1 and E2. IS5 is equal to what? E1 minus E2 divided by ZS1 plus ZS2. Of course, ZS1 is equal to ZS2 1.7. E1 how much? But he is asking per phase values, na? IS5 per phase. Per phase means you have to substitute per phase values. 3300 divided by root 3. Star connected is given, na? 3200 divided by root 3 divided by 1.7 plus 1.7. How much it is? It will be 16.98 amperes. So answer is A. Answer is A is correct. A is correct. Okay. Instead of that, if you do like this, IS5 is equal to simply E1 minus E2. Means if simply you substitute 3300 minus 3200 divided by 1.7 plus 1.7. What is your answer? That your answer will be 29.41. 29.41 amperes. That is what is that answer? Answer is B. B. Okay. And not only that, even if you do this, IS5 is equal to 3300 divided by root 3 minus 3200 divided by root 3 by 1.7 if you take, you will get another answer. What is that answer? 30.96 amperes. 30.96 amperes. Even if you do IS5 is equal to 3300 minus 3200 divided by 1.7, then you will get 58.82 amperes. And what is this answer? Answer is C. This is answer is D. Whatever you do, you will get one answer. So how you will prepare the questions means whatever you do, you will get one answer. Okay. But all answers are wrong, no? Yes. No, wrong. Even if you do here, wrong. Wrong. No. Right? This is only correct. A only correct. The options while he is preparing, all possibilities he will give. All possibilities he will give. Right? Okay. Yeah. If it is delta connected, say, if it is delta connected means directly 3. If it is delta connected, what is your answer? Tell me. If it is delta connected, what is your answer is going to be? Answer is going to be 29.41. You will get 29.41. Answer will be delta means 3300. That is phase current. Phase current. Okay. Yeah. Now. So let us do one more problem. Okay. That will be the last problem. So you are asking to complete by 9, na? Yes. Yes, I will close. But let us do this problem and then question is, two generators rated at 1 rated at 200 megawatt and 400 megawatt. 200 megawatts and 400 megawatts are operating in parallel. Are operating in parallel. Hello. Okay, okay. I am not going to extend, don't worry. Hmm. Yeah. Two generators rated at 200 megawatt and 400 megawatt are operating in parallel. Are operating in parallel. Their governor group characteristics, characters are respectively 4% and 5%. 4% and 5% from no load to full load. From no load to full load. At no load, the system frequency is at no load, the system frequency is 50 hertz. Is 50 hertz. Okay, yes. Now the system frequency will be the system frequency will be A bit 50 hertz, B bit 49 hertz, C bit 51.3 hertz, and C bit 47.7 hertz. 7 hertz. Second question: the load shared by machine 1 is dash and machine 2 is dash. Third question: the maximum load the set can supply maximum load the set can supply without overloading any machine. Without overloading any machine. Is dash. Yeah. This is a question. Two generators rated at 200 megawatt and 400 megawatt are operating in parallel. Their governor characteristics 4%, 5% from no load to full load. No load frequency 50 hertz. Then what is the system frequency? How much? Load shared by machine 1 how much? Machine 2 how much? Maximum load. Okay. Let us solve this. Grouping characteristics based on the grouping. Listen. The data, they are having grouping characteristics. This is first machine is having 4%. And next one is having 5%. 5%. Okay. Yeah. This is 4% and this is 5% group. But what is the no load frequency? No load frequency 50 hertz. No load frequency is 50 hertz. Right? Yeah. Okay. But when see one is at 50 hertz frequency, no load frequency 50 hertz, but when load is increased to, what is the load? Load is, it is 200 megawatt, and this is the 400 megawatt. 200 megawatt, and this is 400 megawatt. 200, 400. Its frequency 50 hertz, no load. Full load, how much frequency? 4% is reduced, means this will be 48 hertz. 48 hertz it is going to be 48. Similarly, second one, no load frequency 50, its full load frequency 5% is reduced, the 47.5. This will be 47.5. This is 48. 48 at full load condition. But when both are connected in parallel, one is not at 48, one is not at 47.5. But both will operate with the same frequency. Set frequency will be same. Set frequency will be same. Okay. These are individual characteristics. This machine, no load 50, as load increases, its frequency decreasing. And when load increases, 4% reduced means it will be 48 hertz, it is decreased. And when load increases, it is reduced to 47.5. But when both connected, they will operate at a common frequency. Let me take a common frequency. Set frequency is this. This is set frequency. I'm taking this as set frequency. Fine, yeah. This is a set frequency F. F I am going to take. This is F. For that, see, this is machine 1 is taking P1. This is taking P2. Machine 1, P1 and P2. So what is a P1? What is a P2 means? See. Let us take, this is 4% decrease, na? This is 4% is reduced. And let us take, this is some X percentage is reduced, X percentage. And this is reduced by 5%. 5%. Now let us apply triangle symmetry. Triangle symmetry. Okay, this is the triangle symmetry. See, this is the point O. Let me take this point O. This is P. This is Q. This is R. This is S. Yes. This is T. This is U. Or else let me take A, B, C, D. O, A, B, C, D instead of PQ. Let me A, B, C, D. O. This is A. This is B, C, D. This is E, F, G. I am making more clear. Otherwise, after getting some idea, directly we can do it. Directly we can do it. Okay. OAB. From the symmetrical right angle triangle. This is one symmetrical right angle triangle OAB. And OCD also another symmetrical right angle triangle. OAB and OCD, symmetrical right angle triangle. And this is another symmetrical right angle triangle, ODE and OFG. OFG. So, from the symmetrical right angle triangle, from the symmetrical right angle triangle, OAB and OCD. The ratios of the base is equal to ratios of the base is equal to the ratios of the height. The ratios of the height. Okay. From symmetrical right angle triangle. So, because both are settled at this common frequency, no? Both are settled at this common frequency, I am assuming. And we are going to find what is that frequency. This is my frequency. This is going to be my frequency. We need to find. So, this is the procedure. Ratios of the height is equal to ratios of the base means, yeah. What is the ratios of the height? Ratios of the base. And the AB divided by CD. AB divided by CD is equal to what? OB by OD. OB by OD. So from this, what is AB? AB is equal to 4%. AB is equal to 200. CD is equal to P1. P1. And then OB is equal to 4%. OD is equal to X percentage. X percentage. X we don't know, na? X we need to find out. Therefore, what is P1? P1 is equal to 50X. This is equation number 1. Equation number 1. Similarly, from the symmetrical right angle triangle, from the symmetrical right angle triangles, ODE and OFG. OD and OFG. ODE and OFG. These are also another symmetrical right angle triangle formation too. OFD, OFG. Their ratios of the base, DE divided by FG. DE divided by FG is equal to what? OD by OF. OD by OF. So from this, what is DE? DE is equal to P2 divided by FG 400. That is equal to what is OD? OD is equal to X percentage. OF is equal to 5%. Then what is P2? P2 is equal to 80X. This is second one, 80X. Now by solving equation 192, solve equation 192. By solving equation 192. 192. And also 3 is there. What is the 3? P1 plus P2 is equal to another relation we know, na? Yes. But P1 plus P2 is equal to what? Both are connected with how much load? Both are connected with the, if the load is 200 and 400, load is 600. P1 plus P2 is equal to 600 megawatt. This is 3. And P1 is equal to how much? 50X. P2 is equal to 80X. That is equal to 600. This is from equation 1, 2 and 3. Therefore, what is X? X is equal to, X is equal to 4.615. 4.615. 4.615. Right? Yeah. Therefore, first question, set frequency is equal to, set frequency, F is equal to 50 minus X percentage is reduced. Na? Yes, X percentage is reduced. Dear students, here it is 50 hertz. But how much it is reduced? Set will be X percentage reduced. X percentage. So 50 minus X percentage of 50. That is equal to 50 minus X percentage. How much? X is 4.615 by 100 percentage means into 50. That is equal to how much? 47.7 hertz. That is equal to 47.7 hertz. That is the answer. First question. And now second question. Second question. Load shared by machine 1. Load shared by machine 1. P1. P1 is equal to how much? P1 is equal to 50X. That is 50 into X is equal to 4.615. Is equal to how much? That is equal to P1. P1 is equal to 230.77. 230.77 megawatts. Similarly, P2 is equal to 80X. 80 into X is equal to 4.615. That is equal to 369.23. 369.23 megawatt. Okay, that is the answer. Now last one is, just 2 minutes. Last one is maximum load the set can supply without overloading any machine. Without overloading any machine. Is there any machine is overloading here? Yes. Which machine is overloading? The first machine is overloading. Actually, it is 200, not 200, but it is taking more load. Overload 230.77 is taking overloading. But without overloading any machine, the set can take how much? Let us see. During that case, we have to take like this. Take like this. This is 400, this is 400, and this is 200. This is 400 megawatt. No load frequency 50 hertz. So, machine, first of all, which machine is overloading? First machine is overloading. Without overloading means how much power it has to take? It has to take at least it is 200. 200 only it can take. The set will operate since, right? Since machine 1 is overloading, right? Therefore, without overloading, the set frequency will be the rated frequency of machine 1. Rated frequency of machine 1. Rated frequency. The set frequency will be taken as that one. So therefore, this will be the set frequency you have to take. Set frequency. And the P1 is 200 megawatt. But what is P2? This is P2. P2 we have to find. Again, apply triangle symmetry. What is P2? P2. This is 4%. And another one is 5%. 5%. Now apply P2. P2 by 400 is equal to how much? P2 by 400 is equal to P2 by 400. P2 means up to 405. Therefore, what is P2? P2 is equal to it is equal to how much? 320. 320 megawatts. Therefore, total load will be how much? Total load is equal to total load. The set can supply. Total load. The set can supply without overloading any machine. Any machine is equal to 200 plus 320. That is equal to 520 megawatt. Okay. 520 megawatt. Right? Right. So this is your question. Now, so I will stop here and we will continue tomorrow. Tomorrow is also class is from 5:30 onwards. Okay. Yeah. Okay. Right. Yeah. I'm unmuting. Anybody is there? You can ask.
Hello, sir.
Hello. Yeah. Tell me.
Sir, in case of change in excitation on no load, sir. Sir, in that you explained like E1, E2, how they will change. That I did not understood the relation between them, sir.
E1 and E2. When excitation of first machine increases, E1 will increase, na?
Yes,
So
sir.
400 is
Through
there.
that only, through that only you explained that I synchronous current now, sir. In that E1 dash minus E2 by that
Yes, yes.
relation.
E1 dash is increased 450 volts. Both are initially 400, 400. And now when excitation increases, E1 has increased to E1 dash, that is 450, say. Then E1 dash is at higher potential. It will drive the synchronizing current. Okay.
Okay, sir.
It will drive.
So
But
now,
that ISY
so now
Tell me,
machine
tell
2 will be magnetizing now, sir. Now.
magnetizing. Why? Because this ISY leads with respect to machine 2. Magnetizing. A magnetizing means your doubt is E2 earlier 400, it will little increase. How
Yes,
much?
sir. That was.
That is 400. 400 to how much? You just take 410, say 410. 410. E2
Okay.
becomes 410. But what about this E1? It earlier 450 I have taken. Now again it will be reduced to some 430 due to demagnetization.
Okay, sir.
430. But what happened when compared with earlier?
It is decreased.
Earlier it was 400 initially. But whatever you do, when excitation of any one machine increases, E1 has increased only. Don't think it is less. Again, it will not come to the 400.
Okay.
It is increased without any magnetization, demagnetization. Sequentially, we are explaining. When excitation increases 400 earlier, 450 it is going. Right? Yes. Second machine 400 say. Immediately synchronizing power will comes into picture. It demagnetizes. It is 450 to 430 say. This is magnetizing. It is 410. Fine? Yeah. But what is the V? V 420. The 430 minus some drop if you take, it is 420. And 420 minus 10 volts drop, it is 410.
Okay, sir. So anyhow, they will come again to 400 only, no, sir.
When excitation of only one machine increase, it will increase, na? V increase. 430 minus 10 volts drop, say 420. Voltage will increase.
Okay, sir.
Voltage, what is the conclusion I have given? When excitation of machine 1 increases, voltage will increase. See, just a minute, wait for some time. I will explain with again diagram, another diagram. Okay, here, let me take more numericals. Okay, no load condition. Initially, E1 is equal to how much? 400. Okay, E2 also equal to 400. Terminal voltage also 400. Fine? Yeah. Terminal voltage 400. This is also 400. This is also 400. Now, when I am increasing excitation of first machine is increased, means E1 increases. E1 increases to 450, say 450. Due to that, it is driving the synchronizing current ISY. Okay, ISY. But what that ISY is doing? Demagnetizing the first machine. It is demagnetizing. Demagnetizing means its voltage will reduce in how much? Say 430. Finally, it is settled at 430 volts. What happened? This one, it is magnetization. It is some 410 volts, say 410 volts. Okay. Now synchronizing current is there. It is 430, 10 volts drop here. 10 volts drop in the impedance. Then what is this voltage? 420 volts. This is 420 means definitely this is also will be 420 volts. 420. And in this also 10 volts drop. Then what is this voltage? 410. 410. So what happened? Terminal voltage it has increased to 420 volts. That's what.
Sir, this one only, sir, my doubt. After all, in steady state, will it be 400 or 420 volts? This is
It will be 400, 420 volts. If you want to again maintain 400, what to do? You have to decrease the excitation of the machine.
Okay. Yes, sir. Yes, sir.
When it is decreased, say again what will happen? ISY still increase, it is more demagnetization, it will becomes less than 430. Still it is going to be reduced. The second machine we are reducing. Finally, terminal voltage also will reduce, it will reduce to 400. Opposite action you need to take.
Okay,
Opposite
sir.
action. Right. Okay. Right. Anyone? Hello? Hello?
Hello, sir.
Yeah, tell me.
Sir, in one numerical of change in excitation, you have taken a resistive load, and you are told that the load will operate at unity power factor and the machines will operate at lagging power factor.
Where isolated?
Yes, sir. The resistive load is connected there in the same figure, sir.
This one?
Previous example.
This one?
Yes,
Huh?
numerical.
This one?
Yes, sir. Yes, sir. This example. Sir, previous slide. Sir, here. Sir, here the machines are operating at lagging load and the load is operating at unity power factor.
Internal power factor is lagging. Psi is lagging. But phi is nothing but angle between V and IA. That is a power factor angle.
Okay, sir. Sir, but in the case of RL load, then what will happen, sir?
Which one? This RL load?
Yes, sir. If instead of resistive load, there is RL or RLC load, then what will be the performance of?
Yes. It is RL load. Say it is RL load. How much excitation you have given, that will decide. It is again depends on the how much excitation. A numerical question is given, then you can calculate. You will say exactly.
Sir, what is the effect of power factor on on load and at what power factor machines will operate in that case?
Which machine?
Sir,
now you want to change
alternators.
load. You want to change this load. Which power factor? 0.8 lagging and say. Okay.
Yes.
Load power factor is not going to be changed because load power factor, what happened? Voltage and current.
Yes, sir. Hello, sir.
X same, R same, load power factor same. But machine power factors are going to be changes mainly. Machine power factors only will change.
Okay, sir. Sir, that's it. No, I am asking, sir. Sir, what will be the effect on machine power factor in that case?
Yeah, machine power factor 0.8 lagging. Say, yeah. See, this is IA1 is lagging. IA1 is lagging. ISY also lagging, na?
Yes,
more
sir.
lagging. First machine is going to be more lagging. And a 0.8 lag means it may be 0.6 lagging.
Lag.
Okay, sir.
More lagging. It will becomes less lagging. From 0.8, say 0.9 it may be. And it is going more inductive nature. Because already it is delivering reactive power. This is also current lags, na? Still ISY. It is still more lagging.
Yes, sir.
Okay.
Okay, sir.
Right. Fine.
Sir, both the alternators, both alternators will operate at lagging power factor. More lagging means.
Yes. And still, if you increase very large increase in excitation, there may be a choice of E2 may goes to leading also. Earlier IA2 having both IA cos phi, IA sin phi, no?
Yes, sir.
Now this ISY is coming now. That ISY is more than this is actual reactive power. Then it will become minus. If you increase excitation of first machine very very high, say there is a choice of second machine may go to the leading power, leading reactive, because IA2 having both IA sin phi, IA cos phi plus J IA sin phi, say. But this ISY is more than this IA J sin phi. Now it will becomes reverse. It may becomes leading.
Okay, sir.
Are you getting? The point is,
Yes, sir.
see, 2 is equal to what? IA2 cos phi plus JIA sin phi.
Sign.
Plus JIA sin phi. Let me write here. Is IA2 is equal to IA cos phi plus JIA sin phi. This is reactive component, na? Yes. But later when excitation is increased, what is going to be IA2 dash? IA cos phi plus JIA sin phi minus ISY. But minus ISY also equal to, that is also I sin phi, na?
Yes, sir.
I sin phi. Right? Now this is a matter. Among these two, which is more? If this I sin phi is more, say, then it will go to leading.
Okay, sir. It means among those which is more,
Yes.
the power factor will depends on that.
Depends on that. But it is ISY is depends upon how much excitation you have given.
Yes, sir.
Right.
Okay, sir.
Okay.
Got it.
Yeah. Anyone is there? Hello?
Hello, sir.
Yeah.
Sir, there is one more doubt in yesterday's class, sir. Sir, we are taking, sir, phasor rotating in a counterclockwise direction, but we have taken the phase sequence in clockwise direction. So why, sir, we have taken?
When phasors are rotating counterclockwise direction, phase sequence clockwise only. You tell me, these are the phasors. R, Y, B. Okay. Rotation counterclockwise. Fine. Right? What is R?
Yes, sir.
ER at an angle 0, EY at an angle minus 120, EB at an angle minus 240. Then what is the phase sequence? RYB.
Yes, sir.
Right? RYB. As I told, if an observer is standing here, how you will feel when phase are going? Okay? Or you can take observer is standing here, say. For example, observer is standing here. Order at which phasor crosses? R phasor will cross. After 120 degrees, Y phasor will crosses. When phasors are rotating counterclockwise.
Yes, sir.
And when phasors are rotating counterclockwise, phase sequence can be observed in clockwise, reverse direction. But this is the best thing. Whenever you get doubt, you just go through this. Okay? Yeah.
Okay, sir.
Fine. Yeah. Hello, anyone? Hello? Next. Unmuting. Hello?
Hello, sir.
Hello? Tell me, ma'am.
Sir, in the last problem which we did,
yeah.
sir, in that, I don't understand how we drew the triangle, sir. Could you explain that? This triangle diagram which we drawn.
Diagram is doubt or?
Diagram is doubt, sir.
Drooping characteristics, there are drooping characteristics. Drooping means, for example, see, this is at zero load condition, I am getting 50 Hz frequency, 50 Hz, right? And when load increases, its frequency will decrease. When load increases to here, say, its frequency has come down, it is reduced. This is frequency. Reduced, frequency has reduced.
Okay.
And when load increased, again its frequency is reduced. This is the frequency. And frequency is reduced to this much. Right? 100 say. This is 200. And still when it is increased to 300, now its load is decreased. Right? And it is 400 say, it is this much. It is this much. And it is finally 52. How much it is? It becomes 47.5 hertz it becomes. Now if you join all these things, that is itself this triangle.
Yes, sir.
Right side triangle.
Yes,
this is the right side triangle for first machine. One machine say. Other machine, I am taking left side. This is left side. Because left side, this is power. The x-axis is power.
Sir.
Okay.
Yes, sir.
X-axis is power. For this also, and this side, see, this is some zero load. This is 50, right?
Yes, sir.
And when load increases to, its frequency decrease. Load increases, its frequency decreasing here. And still when load increases, say, its frequency reduced here. Here,
Okay.
frequency reducing. Like that, when load increases, its frequency reduced to 48. At a 5% reduced means 50, sorry, 4% means how much? 48. 4%, 48. Then this will be the having 4%. This is having 5%.
Okay, sir. So the x-axis would be the power.
Load, power.
Sir.
Okay.
Sir, and one more doubt from yesterday's class.
Ah.
Sir, in three lamp method, that is 3 lamps simultaneously dark and bright, that for making the frequency same as that of the system, existing system, we are actually considering flickering, sir. So when both the frequencies are almost similar, if you're considering the phases also, they'll be rotating together, sir. So then why would there be a flickering in that case, sir? It would be always dark or something like that, sir. If the frequencies become
we need to adjust flickering is as minimum as possible. Slowly dark, slowly bright means frequency almost same. Now you can close the switch, no problem. Not much. Once switch is closed, then they will be both will be settled. Synchronizing power will comes into picture and machine will rotate synchronous speed only. Its frequency is adjusted. Small difference is there also, does not matter, but once machine is connected, they will settle it. It's a rated frequency.
Okay, sir. Okay.
Small flickering. Practically, it is highly difficult to exactly to make the frequency equal.
Sir.
Little difference is there, but when switch is closed, automatically it will adjust.
The synchronizing power will come into.
Yes.
Yeah, sir.
Okay, yeah. Right.
Okay. Thank you.
Right. So I am closing the session. Right.
Hello, sir.
Hello.
The numerical parallel operation of alternator resistive load.
This one,
No, sir. Resistive load.
Resistive load.
Phasor. There is this. No, sir. No, sir. Previous.
This one,
Yes, sir. That phasor diagram. I didn't understand it.
Okay, I
Hello,
will
sir.
do one thing. I will do tomorrow. I will again explain this. You want now? Okay.
Yes, sir.
See, just a minute. For machine 1, I am drawing the phasor diagram right side. This is V. Okay. For second machine, I am taking V this side.
Sir, negative.
Don't think it is not negative. If I draw on both sides, both will be overlapped.
Okay.
Right?
Okay.
Or else if you want to interest, you can take on both are same side also. Okay, let me draw. Both are on same side. This is V, na? V. This is IA1 is equal to IA2, say. IA1 is equal to IA2, right? V common. Then this is IARA.
Okay.
V. This is IARA. IAXES. IAXES. Okay. This is what? E. E1 is equal to E2 now. This is the phasor diagram. Both are overlapped one over other. Two phasors, they are one over other. IARE, IAXES. Right? Both are operating at UPF. UPF means current is in phase with V.
Okay.
Now, if increase excitation of first machine, and this is what E1 dash is increased. E2 is less, E1 dash increase. Now ESY will be in this direction. This is ESY. ESY. When that is ESY means this will be ISY perpendicular. But ISY for machine 1 in this direction you have to take. Machine 2 you need to take opposite direction. ISY opposite direction. Right? This is for
Okay,
machine
sir.
2. Earlier I have taken voltage reverser, E1 reverser, current has taken same. But now what to do? If you don't
Current
want to change
has
the
to-
E2, ISY with respect to machine 2, ISY in negative direction. Na?
Okay, okay.
Generator, first generator delivering, second machine taking. Okay?
Okay.
Now you take this resultant is how much? What will be the resultant? Let us see. Resultant is going to be for first machine. This is the resultant. This is the resultant. This is the resultant means this will be the IA1 dash. This is IA. IA1 dash. Okay. Similarly, and for second machine, this is the resultant of these two. Resultant of these two. Then how it will be? This is IA2. Now you see V common. So what is its power factor? First machine power factor is this one. Second machine power factor this two. Okay. This you take V na. This is V. So what happened? First machine is lagging. Second machine is leading. Right?
Okay, okay. Okay.
And if you want for earlier diagram, first diagram, see earlier whatever I explained, listen. If you want with the same diagram, see this is V I am taking for first machine, second machine, left side I am taking. Don't think it is not negative, left side. Instead of overlapping one over other, I am taking. This is V. This is IA1. IA1. Okay. This is IA2 for second machine, IA2. Right? Yeah. Now IARA, IAXES. IAXES. What is this? This is E1. E1. Right? Yeah.
Yes, sir.
What is the power factor first of all? Power factor is angle between V and IA you have to take. V and IA. V and IA. That is UPF. But even I1 it is psi. With respect to E, IA1 lags. Why? Because machine inductance will be there. Na? Machine winding. Though load is resistive, but winding impedance will be there. That's the reason IA1 lag. But it is
Okay.
UPF. Similarly, for second machine, IARA, IAXES, and this is E2. Okay? E2. This is V, IARA, IAXES. Fine, E1 and E2 both are in opposite direction? Yes. But now if you increase excitation, up to here it is clear, na?
Yes, sir.
Now if you increase excitation, first machine excitation, E1 dash is increased. E1 dash is increased. E1 dash. When E1 dash is increased, ESY will be here. This is ESY. Okay? ESY will be along the bigger vector. When this is ESY means what is ISY? ISY will be in this direction. This is ISY. That lags ESY by 90. When that is ISY means, now what is the resultant of both? Is the resultant of both, na? Yes. So this is IA1. Right? Yeah. For second machine, resultant of these two, this and this resultant, ISY. Okay, are you getting? IA1 dash is equal to IA1 plus ISY, but IA2 dash is equal to, that is also IA1, IA2 plus ISY. ISY common. So that's the reason resultant of these two you have to take. This one and this one. Okay. So this is IA2 dash. IA2 dash. Okay. Then what is the power factor of first machine? This is the power factor of first machine. Second machine, this is the power factor. Now tell me what happened. This current lags. IA1 lags V, but IA2 leads V. IA2 is leading or not in this
Okay,
direction?
okay, sir.
That's what. Right?
Okay, sir. Thank you, sir.
Okay. Yeah. Now I'm closing. We'll meet tomorrow.